हाँ ठीक. Good afternoon, good afternoon. Sir, can you please repeat yesterday's 2 power I sum? Okay. Good afternoon, sir. Good afternoon. Okay. Good afternoon. Good afternoon. Okay. Okay. Regarding repetition, I guess that I have already solved it in the previous class. I would recommend that you again watch this previous lecture, and again, if you have some doubts, then we will again solve that particular thing in the class. Okay. So today we'll be starting with the calculus portion. Duster. Calculus, right? Okay. But I didn't understand. Okay, so now let us understand this 2 raised to power I. 2 raised to the power I. So how to solve this type of question 2 raised to the power I? So this particular thing can be written as 2 raised to the power I can be written as, let 2 raised to the power I is equals to x plus I into y. It will be a complex number. It will be a complex number. So let me take the logarithm of this. So I of log, which log? Log base e. Log base e2 is equals to log of x plus I into y. X plus I into y. And what is the log of x plus I into y? That is half of log x square plus y square, x square plus y square, and plus I of tan inverse y upon x. Tan inverse y upon x. हाँ ठीक. हाँ ये ऊपर आ गया था बॉटल वाला. Okay, so log of this much. Now let me do one thing. I into log base e2 is equal to half of, now this x plus I into y. X plus I into y is this whatever we have, right? So log base e2 can be written as 0 plus, this particular thing can be written as 0 plus, let me check it here. So it can be written as log x plus I into y, x plus I into y, and this can be written as x plus I into y can be written as it can be written as I into log base e of 2. So this can be written as 0 plus I log base e into 2. 0 plus I log base e into 2. So 0 plus I log base e into 2. So it can be written as like this. Okay. It can be written as like this. So now what we can do is that in this particular question, what we can do is that, so this particular question, what we can do is that, so this x can be compared with 0, and the y can be compared with log base e into 2. Log base e into 2. That is how the y can be compared, log base e into 2. Okay, let me do one thing, otherwise it will become complicated. Let me do one thing. So this 2 raised to the power I, it can be written as, so 2 raised to the power I can be written as 2 raised to the power log base e I raised to the power I. Log base e I raised to the power I. Okay, this can be written as like this, and let us say 2 raised to the power I is equals to log of, not log of, x plus I into y. X plus I into y. Now let me take log on both sides. If I take log, then if I take the log, then it will come out to be here. That is log e I raised to the power I into log of 2. Log of 2 is equals to log of x plus I into y, is equals to log of x plus I into y. Okay, it can be written as half of log base e of x square plus y square, log base e of x square plus y square plus I into tan inverse y upon x. Tan inverse y upon x. Let me see some comments. Good afternoon. Yes, good afternoon. Yes sir, देख लिया. लास्ट स्टेप कैसे हुआ? कुड नॉट अंडरस्टैंड. लास्ट स्टेप ओके, एक बार चेक करते हैं हमने लास्ट टाइम क्या किया था, उसी को एक बार चेक कर रहे हैं. ठीक है ना, एक बार जरा चेक करना. हमने लास्ट टाइम ये किया था ना हमने. सो 2 raised to the power I is equals to x plus I into y and this much. Okay, so we take log on the both sides, that is I log base e2, I log base e2 is equals to log of x plus log of y. ओके अरे ये तो ऐसे सिंपल हो जाएगा. रुको, इसमें तो इसका जरूरत ही नहीं है इसमें तो. सो दिस मच, सो I log base e into 2 is equals to log of x plus I into y, log of x plus I into y. Okay, so this can be further written as, this can further be written as log of log of half of log of x square plus y square plus tan inverse of y upon x into I. Okay, and this is I log base e into 2, log base e into 2. Now this becomes the real part and this becomes the imaginary part. Now this becomes the real part and this becomes the imaginary part. So I can write that 0 is equals to half of log base e x square plus y square. 0 is equals to this much, and log base e2 is equals to tan inverse of y upon x, tan inverse of y upon x. Now this can further be written as, it will be 0. Okay, it will be 0. It can further be written as e raised to the power 0 is equals to x square plus y square. E raised to power 0 is equals to x square plus y square, and this can be written as log base e2. So log base e2 is 0.6 something, 0.6 something. So tan of log base e2 is equals to y upon x, is equals to y upon x. Now solving these two, you will get the value of x and y. Solving these two, you will get the value of x and y. Okay, so you will be getting x square plus y square is equals to 1, and tan log base e2, tan log base e2, where is the calculator? Tan log base e2, can anybody do the calculation? How much is tan log base e2? Tan log base e2, tan ln of 2, tan ln of 2, it is 0.83, 0.83, it comes out to be 0.83064 is equals to y upon x, is equals to y upon x, and from here I will be getting y is equals to 0.83064 of x. This is equation number 1 and this is equation number 2. Now by solving these two equations you will get the answer. Okay, now the question is, sir, in the previous class we solved it with the help of some the Euler's identity. Now see, this is 2 raised to the power I, so this is real raised to the power imaginary, right? So this is real raised to the power imaginary, real raised to the power imaginary. So Cauchy identity, let me check it again. Cauchy identity can be used for imaginary raised to the power imaginary, imaginary raised to the power imaginary, or real into imaginary raised to the power imaginary, real into imaginary raised to the power imaginary, or a complex number z raised to the power imaginary, complex number z raised to the power imaginary. For these three conditions, the Cauchy's identity can be used. Cauchy's identity can be used. Now this particular thing which is real raised to the power imaginary, that is 2 raised to the power I, it can be easily solved just by taking the logarithm. You will get the answer. So there is no need to worry about it, right? So see here, x square plus y square is equals to 1 and y is equals to coming out to be this much of value. You can get the answer. Okay, you can get the answer. So it will be equal to x square plus 0.83064 x square is equals to 1. Is equals to 1. You will get the answer. Whatever the answer is, you will get the answer. Okay, please make a correction there. In the previous lecture, because I still remember I told you that it is a real raised to the power imaginary. It is real into imaginary raised to the power imaginary. Okay, it is real into imaginary. Real into imaginary raised to the power imaginary, or a complex number raised to the power imaginary, or imaginary raised to the power imaginary. For all these cases, the Euler's identity can be used. For all these cases, the Euler's identity can be used. If it is a real raised to the power imaginary, then simply you can get the answer. If it is real raised to the power imaginary, then simply you can get the answer. Good afternoon everyone. Good afternoon. Good afternoon. Good afternoon. चलिए आगे बढ़ते हैं, ठीक है ना, अपने मेन टॉपिक पे बढ़ते हैं अपना. ये है कैलकुलस. द नेक्स्ट टॉपिक इज कैलकुलस. Now in calculus, what we'll be discussing? So first we'll be discussing some formulae, some important formulae. Some important formulae we will be discussing. Okay, I know that most of you remember some formulae, some important formulae of integration and differentiation. But when I was preparing for GATE examination and when I first studied the mathematics portion, I was not able to get some formulae which I had already studied in class 12th, because it is a long gap, right? 3 or 4 years of long gap, and then you start preparing for GATE examination, so you forget some formulae. So those formulae of integration and differentiation are important. I will be writing the formulae. Okay, some you might be remembering, some you might not be remembering, but these are important. The next topic we'll be discussing about the limit, continuity and differentiability. Limit, continuity and differentiability. Next we'll be discussing about the Taylor series. Taylor series. Next we'll be discussing about, after Taylor series, we'll be discussing about the partial differentiation. Partial differentiation and total differentiation concept. Then we'll be discussing about, in limit and differentiability itself, we'll be discussing about the Rolle's mean value theorem, MVT, and the Lagrange mean value theorem. Okay, mean value theorems we'll be discussing, both Rolle's and Lagrange. Rolle's and Lagrange mean value theorem. Then we'll be discussing about the maxima and minima concept. Maxima and minima concept. After this, we'll be discussing about the improper integrals. Improper integrals. And then last, we'll be discussing about the vector identities. Vector identities. So these are the few topics we'll be discussing in calculus portion. Okay, so now let us start with the first portion, that is the some important formulae. So some important formulae are very important for you to remember, because recently when I was taking a class, okay, so some student told me, sir, how have you got this formula? I told him that go to class 12th, R.D. Sharma, whatever book you have, and remember these formulae, okay. But these formulae are very important. So now let us understand about some important formulae. In class 12th, we used to say d by dx. In engineering mathematics, the d by dx has been converted into just small capital D. So d by dx is capital D. So wherever I will be using capital D, it means d by dx. Where I will be using capital D, it means d by dx. In differential equation, we will be discussing in detail about this. Capital D, okay, capital D, small d, all these things we will be discussing in or differential equations. So now let us start with some important formulae. First one is d of the first important formula, okay. First important formula is d n ax plus b raised to the power m. It means that you are doing the differentiation of this function for n number of times. D raised to the power n. It means that d in the order n, d x of order n of ax plus b raised to the power m. So this will be equal to, if you keep on doing it, it will be m, then m minus 1, then m minus 2, m minus 3 and so on up to n number of times, okay. So it will be equal to m minus 1, m minus 2, okay, m minus 1, m minus 2 and so on to m minus 3 and so on to m minus n plus 1, m minus n plus 1, and the last which you will be getting is a raised to the power n, a raised to the power n into a raised to the power n into ax plus b raised to the power m minus n, okay, ax plus b raised to the power m minus n, raised to the power m minus n. This is the number one formula which will be frequently used in calculus. ओके सर tan ln of 2, देखो मैंने तो जो है उस पे किया था, नेट पे किया था, एक बार दोबारा चेक कर, मेरे पास कैलकुलेटर नहीं है ना, तो दोबारा चेक कर लेते हैं. यू आर सेइंग दैट सर tan ln of 2, लेट मी चेक इट अगेन. tan ln of 2, tan ln of 2, it is showing 0.8306. I don't know whether it is showing correct or not. It is showing 0.8306, tan ln of 2. Okay. You do it with the help of scientific calculator. See what are you getting. 0.0. You are getting 0.012. Okay. You are getting Yes. Good afternoon, everyone. Good afternoon. You are getting 0.012. On the internet, it is showing 0.083. Let me again check it. It is 0.83064. 0.83064. Please check it again. Tan of ln of 2, it is 0.83064. This is what I am getting on Google if I type this particular thing. Okay, I also got 0.012. You also got 0.012, Aishwarya. Okay, so I don't know whether there is some mistake with the Google or not. Okay, but in Google, if you type, you can also type in your, you can say browser also, tan ln of 2. Tan ln of 2, you will be getting 0.83064. This is what I am getting in radians. This is what I am getting. So dn ax plus b m is equals to m into m minus 1, m minus 2, m minus 3 and so on to m minus n plus 1 a raised to power n ax plus b m minus n. The number 2 formula which is important, which will be used in calculation, is if you do the differentiation of up to n times, if you do the differentiation of log of ax plus b, if you do the differentiation of up to n times of log of ax plus b, you will be getting minus 1 raised to the power n minus 1. Now the question is that, sir, how are you writing this formulae? You can put any value of m or n. Let us say you put 3 or you put it as 2. You will be seeing that this is satisfying this particular series. Similarly, this also that will be satisfying this particular series. N minus 1 raised to a into a raised to power n divided by ax plus b raised to the power n. Ax plus b raised to the power n. ax plus b raised to the power n, not x, n. This is number 2 formula which will be frequently used in calculus. The question is that, sir, do I have to remember the formula? See, sometimes I have seen in examination that the options are given such like this. The options are given like this. You will not be given an exact value. You will be given a function. And if you do not know whether this particular function, after doing the differentiation n number of times, it gives you this result, you will not be able to get the answer. At that time, what the students do is that they put the values. Okay, put n equal to 1, put n equal to 2, whether it is satisfying the options or not, they do that thing. And sometimes they get the wrong answers. Okay, so it is better if you remember these formulae. Number 3 formula which will be used in calculus, dn amx will give you m raised to the power n log a raised to the power n log a raised to the power n and amx. Number 3 formula. So these formulae, first type A for differentiation, type 2 formulae will be for integration. So 1, 2, 3 formulae. Okay, some more formulae. Number 4. Number 4th formula. So this is not important, this is not important. Yeah, this is important. D raised to the power n sine of ax plus b. If you do it, the sine of ax plus b, you will be getting an sine of ax plus b n pi by 2. Ax plus b plus n pi by 2. Ax plus b n pi by 2. Similarly for cos, you will be getting 5th dn cos of ax plus b is equals to a raised to the power n cos of ax plus b plus n pi by 2. See, when I will be telling about the Fourier series, when we will be discussing about the Fourier series, there these formulae also become important in Fourier series. These formulae become important in Fourier series. Okay, to get the value of a naught, to get the value of b naught, to get the value of the function, we have the Fourier cosine series, Fourier sine series. Okay, how to go with the Fourier series, then at that point of time these formulae will be very important. Okay, question number 1 to 1. Yes, today I will explain it. Let me first of all do the calculus at the end of this day. Today I will explain the question number 121. Don't worry. Okay, so in question number 121, when I searched it, so there is a mistake with the printing mistake. So I was telling you that it should have been dou x and it was written dou y. Okay, so that is the problem with that particular question. So question number 6. Function number 6. The next is, okay, this is bx plus c, not important. This is also not important. Okay, these are more than enough. 5, more than enough for differentiation. Next one is the integration. You note it down. Next one is about the integration. integration. See, after this important formula, I will be telling you the limit, continuity and differentiability, right? In limit, continuity and differentiability, one topic is very, very, very important. That is the L'Hospital's rule, okay? So, you must have discussed the L'Hospital's rule in class 12th or 11th also. But here in engineering mathematics, it has a little bit of advanced version of L'Hospital's rule. So, L'Hospital's rule is very important. This year also there was a question on L'Hospital's rule. Previous to previous year question, year also there was a question on L'Hospital's rule. So, almost every successive years there have been questions on L'Hospital's rule. Okay. Sometimes the questions are very easy and sometimes the questions are very complicated. So, the next topic will be the limit, continuity and differentiability. We will be focusing majorly on the L'Hospital's rule. Okay. So, next one is the integration. So, integration, we have a lot of formulae, but I will be only telling you important formulae which will be used in calculus. The first formula that will be used here, number 1, integration of, so x raised to the power n you already know, no need to tell you also, that is x into n plus 1 upon n plus 1 plus c, okay, that you already know. Number 2 formula which will be frequently used in calculus would be this formula, yes. Okay, let me write down that all those formulae because some of you might have forgot these formulae. So, log of x plus c. Number 3 formula, integration of e raised to the power x dx is equals to e raised to the power x plus c. Number 4 integral formula of sin x, you write it down as the minus cos x plus c. So, next one would be the integration of sin x dx is equals to minus cos of x plus c. Okay. Next one you can write about the cos x you already know. Fifth one, cos x you already know. Cos of x dx is equals to sin of x plus c. Sixth formula, integration of sec x, right? Integration of sec square x. Integration of sec square x dx, you write it down as tan x plus c. Number 7. Okay, so some of you might be remembering those formulae, but I know that a lot of you have forgot these formulae, especially those who are studying mathematics for the very first time for gate purpose. Okay, so some of you would have already studied mathematics, they must be remembering these formulae who are repeating it twice, okay, the mathematics portion. But some of you who are studying mathematics for the very first time, you must have forgot these formulae, so they will be frequently used in calculus portion. So you should remember these formulae. The next formula would be cosec x square x, cosec square x dx is equals to minus cot x plus c, minus cot x plus c. Next formula would be sec x tan x, integration of minus cos x plus c. So that is minus yes, sec x plus c. Number 9 formula that will be frequently used in this particular thing is that cosec x cot x, plus cosec x cot x dx is equals to minus cosec x plus c. And next one is tan x. For tan x we have log sec x plus c. Integration of tan x dx is equals to log of sec x plus c, log of sec x plus c. So these are the basic formula that we have already discussed in class 12th and 11th also. Class 12th and 11th also, these formula you already know it, but still I am writing it because these will be frequently used in examination. Yes sir, degree और रेडियन, तो रेडियन से वेरिएशन आ रहा है, हाँ डिग्री और रेडियन से वेरिएशन आएगा, ठीक है ना। तो अपने को किस में डालना है, अपने को रेडियन में डालना है, उसमें डिग्री में नहीं डालना है, उसमें रेडियन में डालना है। इंटीग्रेशन ऑफ cot x dx is equals to log sin x plus c, log sin x plus c. And the proof also you must be knowing, right? For example, it is cot x, that is cos x upon sin x. We put sin x is equals to t. The numerator gets cancelled out. The numerator gets cancelled out, and hence you get the value of log of sin x plus c. This thing you must be knowing, okay? Now, tell me one thing clearly, okay? Such bolna. How many of you remember all these formulae? Okay? Just type, sir, I remember, or yes, sir, I know. How many of you remember these formulae, and how many of you have forgot these formulae? If you have forgot, you just type forgot. If you remember, just type remember. Okay? Now I want to see how many of you remember these formulae and how many of you have forgot these formulae. Because when I was preparing for GATE examination and when I picked the books of mathematics, I was not able to remember those formulae which I studied in class 12th and 11th. So how many of you remember these formulae and how many of you have forgot? Okay, not me. Okay, Ash Rai is saying not. Okay, forgot. Aditya has also said forgot, right? Okay, so we have to be genuine, right? You have to speak the truth. Because I have spoken the truth. Because when I was preparing, I did not remember these formulae. Okay, I did not know the formulae. Yes, sir. Only first 5 remember for integration. Okay, some I remember. Yes. Okay, some. You remember some. Okay, Abhishek is remembering some formulae. Okay. Okay, 2 formulae I forgot. Okay, forgot. No, forgot. Only remembering some. Okay, forgot. See that. So we have to be genuine, right? So we have to speak the truth. So there is nothing to shy about if you have forgot the formulae. So when I was preparing for the GATE exam, I forgot most of the formulae. This is a very common formula. Everybody knows. This also almost everybody knows. E raised to power x, very simple. I knew sin x is sin x is minus cos x and cos x is sin x. Okay, that thing I knew because in differentiation we have the opposite sign. And sec square x I did not know, by the way. So when I preparing for the GATE examination, I picked up R.D. Sharma and then remembered the formula of sec square x and these formulae also. I did not know these formulae. So because there is a long gap, right? 4 years is a long gap. We start preparing for GATE examination. Started preparing when I was in 6th semester. So it's a long gap. Okay, so we forget these formulae. Remember only first 4. कुछ याद है only first 4. हाँ हो जाता है. बट एग्जाम में अगर ऐसे क्वेश्चंस आ गए जहां पे आपको यूज करने पड़ेंगे फॉर्मूला, तो प्रॉब्लम हो जाएगी. तो इसलिए मैंने सारे फॉर्मूले लिख दिए आपके की जगह पे, ताकि आपको आर.डी. शर्मा देखनी ना पड़े आपको. यू डोंट हैव टू सी आर.डी. शर्मा अगेन, यू जस्ट सी दोस फॉर्मूले, दैट विल बी मोर देन सफिशिएंट. ओके, नंबर 12. अब थोड़ा आगे बढ़ते हैं, थोड़ा हाई लेवल पे चलते हैं. नंबर 12, इंटीग्रेशन ऑफ 1 अपॉन under root of 1 minus x square dx is equal to sin inverse x or minus cos inverse x. Sin inverse x or minus cos inverse x plus c. Sin inverse x or minus cos inverse x plus c. Number 13. So this formula in engineering mathematics, it is used for the calculation of gamma function and beta function. Now what is a beta function, what is a gamma function, I will be telling you when I will be discussing those functions, beta and gamma function. Number 13. So 1 upon, this you already know, this thing you must be knowing, 1 upon 1 plus x square dx is tan inverse x plus c. Tan inverse x plus c. Tan inverse x plus c. If it is 1 upon a square plus x square dx, then it will be equal to 1 upon a tan inverse x upon a plus c. Number 15. One upon x under root of x square minus 1 dx is equals to sec inverse x plus c or minus cosec inverse x plus c. Sec inverse x plus c or minus cosec inverse x plus c. Cosec inverse x plus c. 16, which will be frequently used. Integration of sine hyperbolic x. Integration of sine hyperbolic x dx. So you know the formula of sine hyperbolic x. N stands for negative. So e raised to the power x minus e raised to the power minus divided by 2. If you do it, you will be getting cos hyperbolic x. Cos hyperbolic x plus c. And similarly for cos, it will be minus sign. Okay, let me write it also. For cos hyperbolic x dx, it will be minus sine hyperbolic x plus c. Minus sine hyperbolic x plus c. Next one is, now this formula is also important, formula number 18. This is also very important. Integration of 1 upon under root of x square minus a square. Under root of x square minus a square. This formula dx. This will be equal to log of x plus under root x square minus ax, log of x plus under root of x square minus ax, minus a square and plus c. ओके इसको नोट करो आप. एक दो फॉर्मूले हो रहे हैं उसके बारे में बात कर लेते हैं. Now one more very important thing you should remember. See, if a function is in numerator divided by denominator, if a function is like this, numerator divided by denominator, and the numerator is a differentiation of denominator, and the numerator is a differentiation of the denominator, then that particular thing, the integration of that thing becomes log of denominator plus c. Log of denominator plus c. For example, it was, let us say it was this. Sin x upon, what is this? Tan x. Tan x is sin x upon cos x. So the sin x is the differentiation of cos x in negative sign. It is the differentiation of cos x. So that thing will be equal to log of cos, log of 1 upon cos x plus c. That is log of sec x plus c. So I will be telling you that also because that is also important. So that is the formula number 18. Formula number 19, which will be frequently used. Integration of dx upon x square minus ax. X square minus ax. So it will be equal to 1 upon 2a log of x minus a divided by x plus a and plus c. This will also be used very frequently. Dx upon integration of x square minus ax minus a square. Similarly, if it is a square minus x square, it will be a minus x upon a plus a minus x upon a plus x. If it is like this. Okay. So if it is, let me write it that also. That is, if it is dx upon a square minus x square, it will be equal to 1 upon 2 times of a log of, it will be equal to a plus x upon a minus x plus c. 21. Yeah, the chain rule is also important. Chain rule. Integration of u into v. Integration of u into v is the first function into integral of second minus integral of d by dx of function, first function into integral of second. okay, and plus c into integral of secant. If you further solve it, you will get the chain rule. What is the chain rule? Okay. So from here you will be getting first function into integral of secant minus integral of d by dx of first function into integral of secant. Now it will be equal to first function into integral of secant minus first function integral minus integral of d by dx of first function minus d by dx of first function into integral of secant and plus c. If you further solve it, you will get a sequence. A sequence is there. That is, though you do not have to write this thing, just by looking at this, you can do the integration multiple number of times. So if you solve it, you will be getting like this: u dash integral of v plus u double dash and integral of v like this, okay, and plus c. So now see, first function integral of secant, first function into integral of secant minus d by dx of first function into double integral of secant plus this triple integral of this, and it will be again, if you again solve it, minus triple derivative of this and 4 times of this, okay, again plus 4 times of this and 5 times of this. So that you will be getting a sequence which is called as the chain rule, chain rule. Now regarding chain rule, I will be telling about this chain rule when we will be discussing about, in chain rule we will be discussing about the odd and even function. Odd and even function, there we will be discussing in detail about this chain rule, okay. So chain rule is very important for odd and even function. This chain rule will be very important for odd and even function. So you will get a sequence. So again, you do not have to write all these things. Just by looking at this, in just one line, you can get the integration of this. First function integral of secant minus d by dx of first function into secant. So you will get a sequence. Just by a single line, you will get the whole integral of the function. You don't have to write again and again and again. That is called as the chain rule. So next I was telling you that if the numerator is integration of, if the numerator is a derivative of denominator, then it is equals to log of fx plus c. Log of fx plus c, if it is a derivative. So these are the formulae which will be helpful for us in throughout the calculus. Okay. So let us solve some numericals and then we will proceed to the limit, continuity and differentiability. Okay, and do not think that these are just formulae. So dear students, many times in GATE examination, simple integral has been asked. Simple integral, many times. Now let us solve a few questions. You will get what type of simple integrals have been asked in examination. GATE 2002 civil. GATE 2002 civil. Question is, the value of integration of sine inverse x dx will be option number A, x cos inverse x, option number B, x sine inverse x, Option number C, x cos inverse x plus under root of 1 minus x square plus c, and option number D, x sine inverse x plus under root of 1 minus x square plus c. Let me check the options again. X cos inverse x, x sine inverse x, x cos inverse x plus under root 1 minus x square plus c, and x sine inverse x plus under root of 1 minus x square plus c. So we have to get the value of this. That is the integration of sine inverse x. Sir, in hyperbolic there is no sign change. Let us again check it. So that is the sine hyperbolic x dx integration. Till then you do this. So somebody is saying something, let me check it whether it is correct or not. Integration of e raised to the power x minus e raised to the power minus x divided by 2 dx. So it will be equal to 1 upon 2 integration of e raised to power x is e raised to the power x, and integration of e raised to power minus x, this will be multiplied here. So it will be multiplied here, it will be plus e raised to the power minus x, okay, e raised to the power minus x, and it will be equal to cos hyperbolic x it will be, okay. And if you do the integration of cos hyperbolic x dx, it will be equal to integration of e raised to the power x plus e raised to the power minus x divided by 2. It will be equal to 1 upon 2 e raised to the power x and minus e raised to the power minus x divided by 2. Sorry, this, so it will be equal to sine hyperbolic x. Yes, very good. So who is this? RK81. Yes, very good. So in hyperbolic, remove the negative sign. So I had said that sine integration of cos hyperbolic x is minus sign. It is not minus sign. It is just plus sine hyperbolic. Please remove the negative sign from the hyperbolic. Okay. So the value of integration of sine inverse x dx will be, so what is the correct answer? Someone is saying D, Gaurav is saying D, okay. 17 में नेगेटिव साइन नहीं आएगा शायद, 17 वही था ना हाइपरबोलिक वाला, अगर वो होगा तो नहीं आएगा उसमें, ठीक है, वेरी गुड. हाइपरबोलिक नो साइन, यस वेरी गुड, नो साइन. Simran is also saying D, Gaurav is also saying D. Okay, Arish is also saying D. Marker, okay. Okay, solution. So this is integration of, try करो, गलत हो कोई बात नहीं, try करो at least. Sine inverse x. So this can be done with the help of chain rule. So let us say we have 1 here. So 1 into sine inverse x dx. 1 into sine inverse x dx. Applying the chain rule or applying the normal formula. So first function into integral of second, okay. So let me say this is the first function because it will be difficult then. Sine inverse x into 1. Sine inverse x into 1. So first function into integral of second minus integral of d by dx of first function, that is 1 upon under root of 1 minus x square, okay, integral of second, that is x upon this thing. Is it so? Integral of first function, integral of d by dx of first function into integral of second. So d by dx of sine inverse x is 1 upon under root of 1 plus x square, 1 minus x square. Under d by dx of, let me again check it. So d by dx of sine inverse x is equals to 1 upon under root of 1 minus x square. So because that is why if you do the integration of this, you get this. Okay. That is why if you do the integration of this, you get this. Correct. Yes. Let me rub this. Now how to solve this? So it will be equal to 1 dx means x dx, or you can say x sine inverse x minus integral of x upon under root of 1 minus x square dx. If there is a formula or not, I don't know, but let me do one thing. Let us say that 1 minus x square is equals to t. Let us put 1 minus x square is equals to t, because I know that the differentiation of 1 minus x square, that is x, it is at the top. So I can do something, okay. So let us say that 1 minus x square is equals to t. So minus 2x dx is equals to dt. Minus 2x dx is equals to dt, okay. So now let me do one thing. So this can be written as x sine inverse x minus integral of x dx becomes equal to dt upon minus 2x, and this under root of 1 minus x square becomes equal to t. So under root of t. So x got cancelled out, this minus becomes plus here. So let me take 1 by 2 common here. So it will be getting x sine inverse x and plus integral of 1 upon root t dt. So that is x sine inverse x plus integration of t raised to the power minus 1 by 2 dt, or it can further be written as x sine inverse x plus t raised to the power minus 1 by 2 plus 1 minus 1 by 2 plus 1 and plus c. So this can further be written as x sine inverse x and root t, and it will be 1 by 2. So 2 times of plus 2 times of, is it 2, right? Minus, yeah, 2 times of root 2 upon root t plus c. Now what is this t? So t is equal to, so 2 was also there, right? So sorry, 2 was also there, so 1 upon 2 was also there. So into 1 upon 2 is also there. So this 2 will also get cancelled out. So what is this t? So t is equal to 1 minus x square. So t is equals to 1 minus x square. So it will be getting x sine inverse x plus 1 upon under root of 1 minus x square plus c. 1 upon under root of 1 minus x square plus c. Half of plus 1 and half of plus 1. Plus 1 upon plus 1, ठीक है. Minus 1 by 2 and plus 1. So it is getting, this is the correct answer, x sine inverse x. But here we are getting 1 minus x square. Have I done any calculation mistake? Please check. Have I done any calculation mistake? It is x upon under root of, so 1 minus x square t, so minus 2x dx is equals to dt. Have I done any calculation mistake? Because this is coming out to be d, but my answer is coming out to be minus 1 by 2. Have I done any calculation mistake? Please tell me. X upon root t dt upon 2. So 2 gets here. 1 by 2. Okay. 1 by 2 minus 1 by 2 and plus 1 and minus 1 by 2 plus 1, that is root t. कहाँ से अंदर नीचे कहाँ से लगे? मैं भी बेवकूफ़ हूँ बिल्कुल एकदम. ये हो गया आपका रूट टी प्लस सी. नीचे कहाँ से आ गया वो? रूट टी प्लस सी. ठीक है, अब ठीक है. एक्स sine inverse x plus under root of 1 minus x square plus c. So I did a mistake. So this was coming out to be t raised to power 1 by 2, but I wrote it in the denominator. Okay, So that is why I was getting minus 1, but this is the correct answer. Yes, sir, in the numerator. Yes, very good, very good. It was in the numerator. So this is the correct answer. D is the correct answer. ठीक है ना. तो जब मैं क्वेश्चन सॉल्व करता हूँ, क्वेश्चन जब होता नहीं है ना, जब कुछ कैलकुलेशन गलती रहती है, तो मैं अपने आप को मतलब आई कर्स माई सेल्फ कि तो बेवकूफ है क्या, कैसी कैसे कैलकुलेशन कर रहा है, तेरे कुछ आता नहीं, तेरे को नर्सरी में होना चाहिए था. मैं अपने आप से ऐसी बातें करता हूँ. ठीक है ना. तो ये मत सोचना कि मैं क्या बोल रहा हूँ. Even when I was preparing for GATE examination, let us say that I am solving some question and I have done a very silly mistake. Then I used to curse myself. Are you nursery student? ऐसे करते हैं क्या? ये कोई तू बेवकूफ है क्या? तू बीटेक है क्या नर्सरी में? मैं अपने आप को ऐसे बोलता था ऐसे उस टाइम पे. तो वो आदत मेरी आज भी है. ठीक है ना. आपकी ऐसी कोई आदत है क्या? मेरी तो ऐसी आदत है अभी भी. यस सर. हाँ, होता है बहुत बार ना. बहुत कई बार बहुत गुस्सा आता है. जैसा आपको पता है कि अरे ये तो मेरे को आंसर आता है इसका. तो और जब आप उसको क्वेश्चन को सॉल्व करने बैठोगे, व्हेन यू स्टार्ट सॉल्विंग द क्वेश्चन, यू विल डू अ वेरी सिली मिस्टेक. वेरी सिली मिस्टेक. I still remember I did 2 silly mistakes in actual GATE examination. Otherwise, I'd have got better marks or much better rank. Okay, so whenever I do mistakes, I curse myself. तू बेवकूफ है क्या यार, तू क्या कर रहा है, पागल वागल हो गया क्या, ऐसे मैं अपने आप को बोलता हूँ. ठीक है ना. तो अगर मैं आपको पढ़ाते वक्त कुछ ऐसे अपने आप को बोलूं तो समझ जाना कि क्या हो रहा है. ठीक है. चलिए आगे बढ़ते हैं. वन मोर क्वेश्चन. Mechanical 2009. Mechanical 2009. So it is the value of integration of e raised to the power x plus e raised to the power minus x divided by e raised to the power x minus e raised to the power minus x dx will be, 4 options are given. It is very simple. 4 options are given. Log of e raised to the power x minus e raised to the power minus x plus c. Option number B, log of e raised to the power x plus e raised to the power x plus c. Option number C, 2 log of e raised to the power x minus e raised to the power minus x plus c, and D, 1 upon 2 log of e raised to the power x plus e raised to the power minus x plus c. A. Gaurav is saying A. Okay. A. Aditya is also very simple, right? I told you that if it is integration of f dash of x upon f of x dx, then we can directly write that log of f of x plus c. Log of f of x plus c, we can directly write it. So it will be equal to log of f of x is what? Denominator, e raised to power x minus e raised to power minus x and plus c, we can directly write it. A. Yes, very good. A is the correct answer. Now let us move to the limit, continuity and differentiability. Limit, continuity and differentiability. Let us say that a curve is there. This is my x-axis, this is my y-axis. Now we are not talking about complex, we are talking about the real numbers, okay, not complex numbers. So let us say a curve is there like this. This curve will have some function. This curve will have some function. Let us say it is f of x. It is a function of f of x. It can be x square plus 3x plus whatever it is, okay. Now what is this limit? So limit is that we want the value of that particular function at a particular point. Let us say this is a particular point C. This is a particular point C. Okay, particular point C. So if you want the value of this particular function at C, we say that limit x tending to C f of x, then that thing is called as the limit. Limit means that you have to get the value of the function at that particular point or near to that particular point. That is the meaning of limit. To be a layman term. Otherwise, we can go a lot of deep also, but that is more than sufficient for our gate purpose, okay. Now what is this continuity? So continuity means that there is no break in the graph. There is no break in the graph. Let us say that there is a break in the graph. If there is a break in the graph and there is a point C, and you find that limit x tending to C minus, what is the C minus? That is left hand side of this point C is not equal to f of x is not equal to limit of x tending to C plus. What is the C plus? That is on the right hand side. On the right hand side of f of x, we say that the function is not continuous. The function is not continuous. See देखो ये continuity limit जो है ना ऐसी हवा बना रखा है, कुछ नहीं है. लिमिट का मतलब क्या है? एक पर्टिकुलर पॉइंट पे अपनी वैल्यू निकालना. कॉन्टिन्यूटी का मतलब क्या है कि ग्राफ कॉन्टिन्यूस है कि नहीं है. सिंपल, ये बस हवा बना रखा है. एंड सी माइनस सी प्लस ऐसी है सब, ठीक है ना. सो what is the meaning of limit and continuity? Limit means you have to get the value of a particular function at a particular point. Simple. And what is continuity? We have to check whether the particular graph is continuous or not. That is the continuity. Okay. So that is more than enough for engineering point of view. So now what is important is that if a graph is continuous, then only it can be differentiable. If a graph is continuous, then only it can be differentiable, okay, along a particular interval. Now what does it mean? What is the differentiability? Differentiability means calculating the slope. What does differentiability means? You are calculating the slope of a graph. So let us say that, let me change the marker. Let us say that this is a continuous graph. This is a continuous graph. Continuous graph means it is a continuous function. There is no break. You can calculate the slope here also, here also, here also, here also. You can calculate your slope anywhere you want. You can calculate the slope anywhere you want. Here also, except at the end points. Because at the end points, you can get infinite number of slopes. So at the end points, one slope can be this. At the end points, one slope can be this, one slope can be this, one slope can be this. You can have infinite number of slopes at the end points. So at the end points, you cannot get the differentiability. But if a graph is continuous, then in the open interval a comma b, the particular function is differentiable. What is this open interval? Open interval means that you are not considering these two values. That is your a, and let us say this is your value b. If you are not considering these two values, that is called as an open interval. And what is a closed interval? Closed interval a comma b, that you are also considering these values also. These values also. That is called as a closed interval. Clear? So it was a very simple concept. So the main concept which lies here in the limit continuity and differentiability is the L'Hospital's rule. Now what is L'Hospital's rule? See, if a function is given to you, let us say a function f of f is given to you, if a function f is given to you, fx is given to you, which is like this, fx divided by gx. It is like this. And you want to calculate the value of, limit x tending to c of f of x. You want to calculate this value. So what you will be doing is that limit of x tending to c f of x upon g of x. But you have found that if you put the value on both these functions, that is limit of x tending to c f of x f of x is equals to 0 and limit of x tending to c g x is also equal to 0 or infinity. What does it infinity means? Infinity means 1 by 0. At that point of time we apply the L'Hospital's rule. So L'Hospital rule can only be applied, we apply L'Hospital's rule. Okay. So how is it derived? So L'Hospital rule is derived with the help of Taylor series, with the Taylor expansion. The L'Hospital rule is derived. When I will be telling you about the Taylor expansion, you will understand that what do I mean, what I want to convey, how it can be derived. You put the value of h equal to 0 and it will be easily derived. Okay. Now, what is L'Hospital's rule? It is only valid if you have a 0 by 0 form or infinity by infinity form. Again, remember this thing. It can only be applied if you have a 0 by 0 form or infinity by infinity form. If you have some other form, 1 raised to the power infinity or 0 raised to the power infinity or 1 upon infinity, it will not be applied. It will only be applied if you have infinity by infinity form or 0 by 0 form. Sir, mode function is continuous or not? You depend, आप mode function को कैसे निकालते हो? आप एक काम करो, ग्राफ बना लो mode function का. जैसे for example mod of x है आपका. Okay, so you have to calculate whether mode function is continuous or not. So what you have to do is that you just make a graph of mode function. So on the positive side it will be like this, and on the negative side it will be like this. Okay, you just make a graph of the mode function and then you will get whether a particular function is continuous or not continuous. Okay, so I was telling you this important thing, that is what I was telling you is that 0 by 0 form, right? So it is only valid for 0 by 0 form and infinity by infinity form. Now the question is, sir, how to apply the L'Hospital's rule? So you note it down, then I will be telling you how to apply the L'Hospital's rule with the help of some gate questions. Okay, no, I think forgot about f of x होगा. I think log. Okay, a. Sir, mode function is, yes, mode function is continuous everywhere. Mode function is continuous. You can see that there is no break in the graph. But if you have a function like this, that is mod of x upon x, then you have to draw the graph and you have to see whether that function is continuous or not. Mod of x upon x. आगे बढ़ते हैं, हाउ टू अप्लाई एल हॉस्पिटल्स रूल. Limit of x tending to c, f of x upon g of x, it can also be written as limit of x tending to c, f of x divided by limit of x tending to c, g of x. It can also be written as like this. Okay, and you have found that if you put the limit c here, you get the value 0. You get the value 0. Then what you have to do is that you have to do the take differentiation of numerator and divide it with the differentiation of denominator. That is limit of x tending to c, f dash of x divided by limit of x tending to c, g dash of x. We have to do the differentiation for the very first time. And then we have to again put the value of limit and we have to see whether it is getting a continuous, whether we are getting a finite value or not. And again if we are getting 0 by 0 form or infinity by infinity form, then again we have to do the second differentiation. Again, limit x tending to c, f double dash of x divided by g double dash of x. And again we have to put the limit and we have to check whether we are getting a finite value or not. Again, if we are not getting a finite value, again do the differentiation. Again do the differentiation. That is triple times, right? Limit of x tending to c, f triple of x divided by f triple of x. You keep on doing the differentiation. If you find that a finite value is coming, well and good. If finite value is not coming, that function cannot be, a limit cannot be found on that particular point, that is x equal to c. Its answer will either be infinity or its answer will be minus infinity. You will get this answer after some time. If you keep on doing the differentiation but still you are not getting the answer, you will get this particular thing. Now let us try to understand with the help of some questions. So question number 1. Question number 1. GATE 2012 electrical. 2012 electrical. 2012 electrical. Question is the value of limit x tending to 0, limit x tending to 0, the value of limit x tending to 0, x cos x minus sin x upon minus sin x divided by x square sin x. X square sin x is option number A minus 1 by 3, option number B plus 1 by 3, option number C minus 1 by 2, and option number D plus 1 by 2. Let me check the question again. X cos x minus sin x divided by x square sin x. हाँ ठीक है. Okay, you note it down. Then I will explain you how to proceed to these questions. Okay. So this is a typical question I have taken. I should have started with the simple questions, but I have not started with the simple questions. So let us do one simple question also. Let us say that f of x is given to you sin of x upon x. f of x is given to you sine of x upon x, and you have to find limit x tending to 0. Limit of x tending to 0. Now if you put x equal to 0 at the numerator, you will be getting sine 0. Sine 0 is 0. And at the denominator also, if you put x equal to 0, you will be getting 0. So if you put 0 here, again 0, and 0 here, again 0, you are getting 0 by 0 form. You are getting 0 by 0 form. So as per the L'Hospital's rule, we have to do the differentiation of the numerator and the differentiation of the denominator. And then we have to put the value of x equal to c. So it can also be written as limit of x tending to 0. What is the differentiation of sin x? That is cos x. And what is the differentiation of x? That is 1. Let us again put the value. Cos 0 is 1. So its answer will come out to be 1. I can directly write that limit of x tending to 0 sine of x upon x, it is equal to 1. This is also one of the formulas. Some people remember this formula. Limit of x tending to 0 sine x upon x is equals to 1. Sometimes it is directly used in examination. Sine x upon x is equals to 1. Now let us try to solve this question. It is a little bit not difficult, but a little bit lengthy question. You have to apply a lot of differentiation in this particular question. So what is the answer of this question? X cos x. ऑडियो डिस्टर्बेंस सर, मोड फंक्शन, ऑडियो डिस्टर्बेंस, आवाज आ रही है आपको? लाला जी शायद इसकी बैटरी कम है, एक बार आप आ जाइए शायद. Okay, Simran is getting A. Simran is getting A. Okay, so one student has got the answer. What about others? One student has got the answer. A, C, somebody is saying C. Okay, देखते हैं इसको C आता है कि नहीं आता. A, C, somebody is saying C. Okay. Now let us understand this. So limit, बैटरी कम होगी इसकी. ये बच्चों का मैसेज आता है कि ऑडियो नहीं आ रहा. उधर आ रहा है आवाज, आपने चेक किया? मैंने अभी बंद किया था. अच्छा, देखना एक बार. हाँ, कट कट के आ रही है. हाँ, अच्छा यहाँ भी था क्या? ध्यान नहीं दिया मैं. ओके, ए, सी, ए. चलो समझते हैं इसको. ठीक है, समझते हैं. जिसको नहीं आया कोई बात नहीं, समझते हैं इसको. लिमिट x टेंडिंग टू 0, x cos x minus sin x divided by x square sin x. Step number 1 should be, you just directly put the value of the limit and see whether you are getting an answer or not. So if you put x equal to 0 here, it is 0, sin 0, 0, 0, 1, 0. So the total answer will be 0 upon 0. It means that we can apply L'Hospital's rule. We can apply L'Hospital's rule. L'Hospital's rule. If it is a 0 by 0 form. Now students are making mistakes is that, suppose that it is coming out to be 1 upon 0, they also apply the L'Hospital. No, it is not valid. So first of all, you have to convert a function in 0 by 0 form. You have to do something with the function so that you get 0 by 0 form. If you are getting 1 by 0 form, please do not apply the L'Hospital, you will get a wrong answer. Don't apply the L'Hospital rule. L'Hospital rule only apply if it is 0 by 0 form or infinity by infinity form. Then only you have to apply the L'Hospital's rule. Now, what do you have to do? Step number 2, taking the differentiation of the numerator and the differentiation of the denominator, and then again apply the limits. Differentiation of numerator. If you have forgot how to do differentiation, understand it. First function into differentiation of cos x is minus sin x, plus second function into differentiation of first one, minus sin x is cos of x, divided by x square sin x. First function into differentiation of second, okay, plus second function into differentiation of first. So cos x got cancelled out. So it will be minus x sin x divided by x square cos x plus 2x sin x plus 2x sin x. Let us again put limit x equal to 0. Limit x tending to 0. Let us again put the limits. Numerator 0, 0, denominator 0, cos 0 is 1, 0, 0. Again we are getting 0 by 0 form. And I told you that if again you are getting 0 by 0 form, again apply L'Hospital's rule. Let us again apply it. It will be equal to first function into derivative of second plus second function into derivative of first, divided by x square. So first function cos x is minus sin x plus second function cos x into 2x, and plus first function cos x sin x is cos x and plus sin x and into 2, plus sin x into 2. So first function into d by dx of second and plus second function into d by dx of first. So x cos x, this. Let me see what we are getting. So it will be equal to minus x cos x minus sin x divided by minus x square sin x plus 2x cos x plus 2x cos x and plus 2 sin x plus 2 sin x. Let me do further solve it. Minus x cos x minus sin x divided by minus x square sin x plus 4x cos x and plus 2 sin of x. Let me again put the limit x tending to 0. If I again put it 0, 0, 0, it is 0 and it is also 0. Again it is coming out to be 0 by 0 form. Again it is coming out to be 0 by 0 form. If it is again coming out to be 0 by 0 form, let us again apply the L'Hospital's rule. So first function minus x into d by dx of second, cos x is sin x minus sin x plus second function into minus 1 and minus cos of x divided by minus first function into d by dx of second plus second function into d by dx of first and plus first function into d by dx of second and plus second function into d by dx of first and plus 2 cos of x plus 2 cos of x. If I again put x equal to 0, it will be equal to, if I put again x equal to 0, it will be equal to x equal to 0, it will be equal to 0 and 0 and it is 0 again. So 0, it is 0, it is 0, it is 0, it is also, it is 4, it is 4 and 2 and 6. I guess that I have done some calculation mistake. Let me again check it. Which calculation mistake have I done? So first function, okay, have I done calculation mistake? Let me rub this. Let me rub this. Let me rub this. Let me see what calculation mistake have I done. First function divided by second, second function divided by first. First function d by dx of second, it is equal to first function into d by dx of second plus second function into d by dx of first divided by first function into d by dx of second plus second function into d by dx of first and plus first function, what is this, sin x square cos x, square cos x. ओहो, यहाँ पे गड़बड़ किया मैंने. ओहो, कैलकुलेशन में थोड़ी मिस्टेक हो गई है, थोड़ी कैलकुलेशन में मिस्टेक हो गई है. ठीक है, एक सेकेंड. थोड़ी कैलकुलेशन में मिस्टेक है, इसको दोबारा करते हैं इसको. ओके, सी कैलकुलेशन में मिस्टेक हो जाती है. ठीक है ना, आपसे भी हो सकती है क्लास में, तो करते हैं. लिमिट ऑफ x टेंडिंग टू 0, फर्स्ट फंक्शन इंटू डी बाई डी एक्स ऑफ सेकेंड, second function d by dx of first minus cos of x divided by first function second d by dx of first. Okay, so again if you put the value of 0, just wait a second. Just wait a second. So it is cos x got cancelled out, okay, and it will be equal to minus x sin x divided by x square cos x plus 2x sin x. X again gets cancelled out, okay, so it will be equal to minus sin x divided by x cos of x and plus 2 sin of x. Now let me do the again differentiation, because if you put 0 here, 0 again 0. So sin x is minus cos x divided by first function into d by dx of second plus second function into d by dx of first, okay, and it will be plus 2 cos of x. If you again put the value 0, it will be equal to minus 1, and if you again put the value 0, it will be 0, and 0 is 1 and 0, yeah, 1 plus 2, it is minus 1 upon 3. Yes, correct. So there was a calculation mistake. The calculation mistake was I did not cancel x out. There was a calculation mistake. I did not cancel x out. See here, see here, when I was doing this calculation, see here, this x could be easily eliminated. This x could be easily eliminated, but I did not eliminate the value of x, and my limit got more complicated, and I was getting all these things. Okay, so the same mistake you might also perform in examination. So the thing is that you write down the differentiation of numerator by denominator, you try to solve it. If something is getting cancelled out, you cancel that particular thing out. Then you will get the exact differentiable in a shorter time, and I am getting it as minus 1 by 3. So I don't know which option it was, A, B or C or D. Let me check the options also. Option number A was minus 1 by 3. Yes, option number A was minus 1 by 3. So this is the correct answer. Minus 1 by 3, this is the correct answer. A is the answer. Put limit in the last step. Yes, सही है, हाँ ठीक है. So A is equals to minus 1 by 3. ठीक है, एक और क्वेश्चन करते हैं. ओके, यहां तक आया समझ में? Have you got it till now? Or shall I again repeat it? Or shall we proceed? You tell me. What should I do? Should I repeat this step? Because this step is not required. Okay, this thing is not required. This thing is not required. This thing is not required. That is more than sufficient. This step, and this step, the last answer, minus 1 by 3. Shall we proceed or shall I repeat this? सर ये क्या हुआ यहाँ पे? बताइए, क्योंकि ये समझ में आएगा तो आगे भी समझ में आ जाएगा. Okay, proceed, sir. Okay, A how is saying proceed. What about others? Shall we proceed or shall we repeat this again? Shall I again explain you how it has come, how the solution has been derived? Proceed. चलो आगे बढ़े फिर. Okay, proceed. ठीक है. चलो आगे बढ़ते हैं. ठीक है, एक और क्वेश्चन करते हैं. Question is, Civil 2012. Question is, limit x tending to 0, x e raised to the power x minus log 1 plus x divided by x square is equal to what? Option number A 0.5, option number B minus 0.5, option number C 1 by 4, and option number D minus 1 by 4. ठीक है, चलो स्टार्ट करते हैं इसको सॉल्यूशन. जिसको लास्ट क्वेश्चन समझ में नहीं आया, who has not got the last question, you just pay attention to this question. You will get how to solve with the help of L'Hospital's rule. Again, I am repeating, L'Hospital rule is very important. This year also, I guarantee one question will be there in examination. I don't know the difficulty level of the question, but one question will be there in examination from this in this year also. Okay. So, L'Hospital's rule. Let us first of all write down the function limit x tending to 0. Then I have x e raised to the power x minus log of 1 plus x divided by x square. Let me put the value 0. If you put 0 here, this is 0. If you put 0 here, log 1. What is log 1? Log 1 is 0. Whether it is natural log or your log based 10, whatever it is. So, log 1 will be equal to 0. So, it means that 0 minus 0 upon 0, it is 0 by 0 form. It is 0 by 0 form. So, we can apply the L'Hospital's rule. Chaliye. Limit x tending to 0. So, what we have to do? Derivative of numerator divided by the derivative of denominator. So, first function into d by dx of second plus second function into d by dx of first minus log of x is 1 upon x. 1 upon 1 plus x divided by 2x. A lot of disturbance in audio. A lot of disturbance in audio. अच्छा करते हैं इसको. Limit of x tending to 0 x one plus x upon 2 times of x upon 2 times of x. Have you got the answer? A. A lot of people have got the answer. So x equal to 0. Again, let me do one thing. If you put here x equal to 0, if you put here x equal to 0, this is 0. E raised to the power 0 is 1. If you put 0 here, so 1 upon 1 plus 0 is 1. So 1 minus 0 is again 0. And if you put 0 here, it is again 0. It is again 0 by 0 form. It is again 0 by 0 form. Third step is, again let us do the dy dx. Okay, so if you again do the derivative of this, what you will be getting is that again the same thing, first function into derivative of second plus second function derivative of first plus e raised to the power x minus denominator dy dx of numerator minus numerator into dy dx of denominator upon 1 plus x whole square divided by 2. Again if you put the values, e raised to the power, again if you put the values, that is e raised to the power 0 here, that will be 0, okay, and e raised to the power 0 will be equal to 1, and this will also be equal to 1, okay, this will also be equal to 1, numerator d by dx of numerator, okay, that is denominator into d by dx of numerator minus numerator into d by dx of denominator divided by 1 plus x square. So 1 plus 1 and it will be equal to plus 1, I guess. It will be equal to plus 1. It will be equal to 0 here. So it will be equal to plus 1 and divided by 2. It is getting 3 by 2, that is 1.5. That is 1.5 I am getting. I am getting 1.5. What about others? Others are getting A, that is 0.5. Let me again check it. So first function into differentiation of second, the second function into differentiation of first minus 1 upon 1 plus x, okay, divided by 2 times of x equal to 0, x if you put 0 here, it is a 0 by 0 form, and it will be equal to x e raised to power x plus second function divided by first, okay, and that will come out to be equal to, me also 3 by 2, everybody is getting 3 by 2. Let me check the answer. X into e raised to power x. Save a second. Let me check the answers. X e raised to power x, this 3 by 2. I am getting 3 by 2. It means that I have to see the options again. The options are, just wait a second. The options are question number 83. Options are अरे मैंने क्वेश्चन नंबर 84 के लिख दिए ऑप्शंस. ओके, मैंने क्वेश्चन नंबर 84 के ऑप्शंस लिख दिए. क्वेश्चन नंबर 84 के ऑप्शंस थे ये वाले. क्वेश्चन नंबर 83 के जो ऑप्शंस हैं आपके, ये हैं आपके 1 by 2, 3 by 2, minus 3 by 2 and minus 1 by 2 and minus 1 by 2. So these are the options. Okay, मैंने क्वेश्चन नंबर 84 के ऑप्शन लिख दिए. 1 by 2, 3 by 2, minus 3 by 2 and minus 1 by 2. So the correct answer is 3 by 2, that is 1.5. This is the correct answer. Option number D is the correct answer. 3 by 2, 3 by 2. Yes, 3 by 2. Let us proceed now. माइक डिस्टर्ब हो रहा है, देखना। एक दो बच्चों को मैसेज तो आया था कि सर डिस्टर्बेंस वाला आई थी। अच्छा, Are you getting the voice now? देखने के बाद आप ला लें। Hello, hello, mic check. Are you getting the voice now? Or do you still have disturbance in the voice? Is it fine now? Sound disturbance. Is it fine now? Is it fine? Is it fine? Is it fine? आवाज आ रही है? Okay, fine, 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 fine. Okay, so I had written the options incorrectly. So this is the option of question number 83. Now let us move forward. See, sometimes while solving a question, the derivative is not sufficient. Sometimes while solving a question, the derivative is not sufficient, or you can say while solving the limit question, the derivative is not sufficient. In some particular questions, we need the help of Taylor series. In some questions, we need the help of Taylor series. Now, what is Taylor series? So, let us understand Taylor series, and then again we will come to the limit continuity. Okay, because in some questions, you cannot solve those questions with the help of normal things. You have to apply the Taylor series. So, what is this Taylor series? Taylor series. अभी ठीक है लाला जी? अभी भी आ रही है? A lot of noise is coming. Okay, disturbance आ रही है? अच्छा अच्छा ठीक है, मैंने देखा नहीं था मैसेज आपका. अभी आ रही disturbance. अभी आ रही है? अब आवाज ठीक है या अभी भी है प्रॉब्लम? हेलो हेलो हेलो, माइक चेक. हेलो, इज इट फाइन? ओके, समवन इज सेइंग फाइन. सही है. अच्छा ठीक है लाला जी सेइंग. ओके. Okay, so I was telling you that while solving the questions of limit continuity and differentiability, sometimes the knowledge of just L'Hospital's rule is not more than sufficient. So we need some extra knowledge. We need some extra knowledge, we need some extra calculation, and that help is being done by this series called as the Taylor series. Okay. Now the question is, sir, in which type of questions the knowledge of L'Hospital rule is not sufficient? Because I feel that L'Hospital rule is more than sufficient. I can apply L'Hospital rule in any type of question. But there are some questions in which the knowledge of just L'Hospital rule is not sufficient. Let me give an example. The example is question Mathematics XC 2019. Mathematics XC 2019. Limit of x tending to 0, sin x upon x, sin of x upon x divided by 1 upon x square. 1 upon x square. Now when you have these types of questions, the knowledge of just L'Hospital's rule is not sufficient. Now you see this, if you put x equal to 0 here, 0. If you put x equal to 0 here, that is 0. So 0 by 0 divided by infinity form. This is 0 by 0 divided by infinity form. Even if you take logarithm, you will not get the answer until and unless you do not know the knowledge of this Taylor series. So 4 options were there. First option was e raised to the power minus 1 by 6. E raised to the power minus 1 by 6. Second option was e raised to the power plus 1 by 6. Plus 1 by 6. Third option was e raised to the power minus 5 by 6. And fourth option was e raised to the power plus 5 by 6. These are the 4 options. Okay. So don't worry, sir, how to solve it? First of all, let us come to this concept, the Taylor series. So Taylor, now why this series is used? So whenever you have a sinusoidal function, or you can say a trigonometric function. So whenever you have a trigonometric function, it can be converted into an algebraic function. It can be converted into algebraic function. If you have a trigonometric function or you have an exponential function, or you have a logarithmic function. These types of functions can be easily converted into algebraic function. It sounds very absurd. Absurd means that, sir, if I draw the graph of sin x, the sin x graph is going like this, sinusoidal function. After 2 pi it is repeating itself. Okay, after 2 pi it is repeating itself. So how can you convert a function into the algebraic function? In complex also I gave you a brief. I directly wrote the formula, that this is the formula of that. Okay, but Taylor said that yes, a particular sinusoidal function or a particular cosine function or trigonometric, any function can be converted into an algebraic function. In mathematics we can do anything. Okay, I will be solving a few numericals in which you will be having improper integrals like this. Integration from minus infinity to infinity, e raised to the power x and dx. Okay, x and dx. So this particular integrals can also be solved by 0 to infinity e raised to the power x dx and plus integration from 0 to 1 and plus integration from minus infinity to 0 e raised to the power x dx and plus 1 to infinity plus 1 to infinity and so on. Okay, in improper integral I will be telling you that also. So in mathematics we can do anything. So in mathematics we can also convert a trigonometric function into an algebraic function. So what did he say? So Taylor said that if a function is given to you, let f of a plus h, let f of a plus h be a function of variable h. H is a variable, h is varying, okay, where f of a plus h be a function of variable h, then f of a plus h, f of a plus h can be explained, can be extended, can be expanded in powers of h, in powers of h. Then f of a plus h can be expanded in powers of h. It can be expanded. How it can be expanded? He said that f of a plus h is equal to f of a plus h is equals to f of a plus h, f dash of a plus h square, f double dash of a divided by 2 factorial plus h cube upon 3 factorial f triple dash of a plus h raised to the power 4 upon 4 factorial f 1 2 3 4 times of derivative of a, and so on. So any function, now this function can be a trigonometric function, this function can be an exponential function, or this function can be a logarithmic function also. It can be extended in this power, these powers. Okay. Now let me do one thing. Instead of h, let me put h is equals to, let h is equals to x minus a. I can do this. Let h is equals to x minus a. Then it will become f of x. If I put it here, f of a plus x minus a. If I put it like this, what I will be getting? I will be getting f of a plus x minus a, f dash of a plus x minus a square divided by 2 factorial f double dash of a plus x minus a cube upon 3 factorial f triple dash of a, and so on. It can be extended in this form also, and this thing becomes f of x. Because this a will get cancelled out, this will become f of x is equals to this thing. So f of x will become equal to this thing, because this a and a will get cancelled out. So this is the Taylor series or Taylor's expansion. Now the question is, sir, how can we use it? So first use is in the expansion of cos x, in the expansion of sin x, in the expansion of e raised to the power x. I have already told you the formula in complex also, but you can also derive those formulae with the help of this also. You can derive it. How can we derive it? Let us understand it also. Okay, you note it down, then I will rub this. Now fine sir, okay, fine, ठीक है. इस क्वेश्चन को मिटाएंगे नहीं, ये तो हम सॉल्व करेंगे ना, इसको ऐसे कर देते हैं इसको. ठीक है, चलो इसको करते हैं, यहां पे करते हैं इसको. Let us say that you want to expand cos of x. Let us say that you want to expand cos of x, which is your f of x. So can I write in this form? Can I write it like this, that it is cos of 0 plus x minus 0? Can I write it like this? Yes, I can write. So if you expand it, because the function is cos, if you expand it, it will be cos of 0 plus x minus 0 f dash of cos of x at x equal to 0 plus f double dash of cos of x at x equal to 0 divided by 2 factorial plus f triple dash of cos of x at x equal to 0 divided by 3 factorial plus f 4 times of dash f 1 2 3 4 cos of x at x equal to 0 divided by 4 factorial and plus so on to infinity, wherever you want to go. Can I write this like this? I can write. What is this cos of 0? Cos of 0 is 1. Simple. Cos of 0 is 1. If you expand it, you will get that expression what we have already discussed in the complex. In the complex, I directly wrote those values. Okay, so if you expand this, you will get that particular thing. Okay, you note it down, then I will expand it also. So it will be equal to f of x. What is this f of x? That is cos of x. So cos of x is equals to cos of 0 is 1 minus what is differentiation of cos x? That is minus sin x. And if you put sin 0, it will be 0. So no need to write this. No need to write this. Plus doing differentiation of cos x for the very first time, minus sin x. Again doing differentiation, minus cos x. And minus cos 0 is 1. So minus 1. Minus cos 0 is minus 1. So minus 1 and we have x here. This x square here. This is x square here. Where is this x square? Oh. X minus 0 square. X minus 0 whole cube. X minus 0 raised to the power 4 and so on. And we have x square also and that will be negative. So minus x square upon 2 factorial. Similarly this 3 times, 1 time sine, 1 time cos and 1 time again sine. So sine 0 0, no need to write this thing. Again that 4 times, so minus minus will become positive. So it will be plus x raised to the power 4 upon 4 factorial. Okay. Similarly if you write it, x raised to the power 6 upon 6 factorial plus x raised to the power 8 upon 8 factorial and so on. Similarly, sin x can be expanded. So sin x and e raised to the power x, these are your homework. These are your homework. How to expand sin x and e raised to the power x, these are your homework. Similar case, that is how we have to expand sin x and e raised to the power x also. Clear? So it's almost time. So how we got h and a? How we got h and a? कौन सा वाला h and a? So f of a plus h is equals to f of a plus h f dash of a plus h square upon 2 factorial f double dash of a and so on. How we got h and a? H and a can be any number. H and a can be any number. Okay, it can be 2 plus 3, 4 plus 5, whatever it is. It can be any number. But the thing is that, so if I put h is equals to x minus a, if I put x is equals to x minus a, because a can be any number, right? A can be 1, 2, 3, 4, 5, 6, whatever, and h can be a variable. H can be a variable because h is a variable, right? In the Taylor expansion, I told that h is a variable. H is a variable. H is a variable from a particular domain, that is a variable. Okay, so if instead of this variable I write the one variable, another variable minus one constant, that doesn't mean anything. Okay, that means the same thing. So if you put it here, f of a plus h minus a, that is f of a plus x minus a, that will become f of x. So from here we have got the Taylor expansion. Okay? So this sin x and e raised to power x are homework for you. And regarding this particular question, so before signing off, let us solve this question. Okay? Before signing off, let us solve this question. Note, always remember that, if you get infinity raised to power infinity, or 0 raised to the power infinity, or 1 raised to the power infinity, etc., these types of forms, convert them into infinity by infinity or 0 by 0 form, and then apply L'Hospital's rule. And then apply L'Hospital rule. And then you apply the L'Hospital rule. Now, how to solve this question? This particular question. So, it is sin x upon 1 upon x square. So, let me do one thing. Let me take log. So, let y is equals to sin of x upon 1 upon x square. Let me take log. Log of y is equals to 1 upon x square log of sin of x upon x. Log of sin of log of x upon x. Log of x upon x. Now, what can be done in this particular function is that, if you put log of 1 is 0, so log of 1 is 0, because this sin x upon x will become equal to 1. That is the standard result. Limit of x tending to 0, sin of x upon x is equals to 1, right? So, if you put it sin of x upon x, that is equal to 1. Log of 1 is 0, so it is 0 by 0 form. Now, this thing has been converted into 0 by 0 form. Now, I can apply the L'Hospital's rule. Now, this thing has been converted. Now, I can apply the L'Hospital's rule. So, log of y will be equal to log of sin of x upon x divided by x square. Sin of x upon x divided by x square. It is 0 by 0 form. So, it is 1 upon sin x. Okay, it will be 1 upon sin. Okay, then it will be complicated. If you solve it like this, it will be complicated. So, let me do one thing. The sin x is equals to x minus x cube upon 3 factorial plus x raised to power 5 upon 5 factorial minus x raised to power 7 upon 7 factorial and plus so on. Let me try whether I can do something with this thing or not. So, if you do this thing, then it will be equal to 3x square and 1 upon this thing. Now, I can do this thing. I can do this thing, because the thing is that if you apply L'Hospital's rule, it will be 1 upon sin of x upon x, and applying the differentiation of this. So, that is the numerator into d by dx of denominator minus numerator d by dx of numerator minus numerator d by dx of denominator divided by x square and divided by 2x. Let me see whether I get something or not from here. So, if you solve it, you will be getting x upon sin x upon sin x, and it will be x cos of x minus sin of x divided by x and divided by 2x. X gets cancelled out here. Okay, it is again x cos of x minus sin of x divided by 2x sin of x. 2x sin of x. It gets like this. Okay, and if you put 0 here, it will again be 0 by 0 form. If you again solve it, you will be getting. So, if I take 1 by 2 common here, let me again try to solve it here. If I take 1 by 2 common here, okay, so that is x cos x minus sin of x divided by x sin x divided by x sin x. Okay, let me do one thing. If you do it like this, 0, again it will not be defined, it will be 1 by 2. So first function into d by dx of second, okay, plus second function into d by dx of first, and minus cos of x divided by, again the same thing, first function into d by dx of second plus second function into d by dx of first, and again doing the same thing. It will be a very long task. It will be a very long task. So what we can do is that, so you will find that you will keep on increasing. It will keep on increasing. Again doing differentiation, it will keep on increasing. So what we can do is that in this particular step, if you directly put this value, the x at the denominator will get cancelled out. And if you do the differentiation, then this will also get cancelled out. And the final answer that you will be getting is 1 by 2. Let me check the answer again. Yes, the 1 by 2 will be the final answer that you will be getting after solving it. So I am taking it as a homework. In next class, we will be discussing this particular question in this is the first question that we will be discussing in the next class. So this is a homework for you, plus e raised to the power x expansion is a homework for you, and plus sine of x expansion. So these 1, 2 and this 3. So these 3 are the homework for you. Regarding question number 121, somebody was asking me, sir, question number 121. Question number 121. So question number 121 was, a function was given to us and it was analytic in nature. W of z was given to us and it was analytic in nature, that is u x comma y plus I v x comma y. It was analytic in nature. If a function is analytic in nature, what happens is that this rule holds good, that is dou u upon dou x is equals to dou v upon dou y, and dou u upon dou y is equals to minus dou v upon dou x. Okay, this rule it holds good if it is an analytic function. Now in that particular thing, the dou f upon dou z, it will come out to be, from the Riemann-Cauchy equation, it will come out to be equal to dou u upon dou x plus I dou v upon dou y, because this function is in a variable of x and y. So first we have to do the differentiation with respect to x, and then we have to do the differentiation with respect to y, and both should come out to be equal. Why? Because it is analytic function, it is continuous and differentiable everywhere in a particular domain. If it is continuous and differentiable, it means that I will be getting limits equal to 0, limits equal, right? That is limit of x tending to, or u tending to x should be equal to limit of v tending to y. So both limits should come out to be equal, or you can say that the slope from both the ends should be equal. Either you are taking it from the x direction or you are taking it from the y direction, your slope should come out to be equal of that particular function. So this is coming out to be like this. If you do it with respect to dou x, if you do it with respect to y, then it will come out to be dou u upon dou y plus I dou v upon dou y. This thing will come out, right? So and these two should be equal. These two should be equal, that is dou u upon dou x plus I dou v upon dou x is equals to dou u upon dou y plus I dou v upon dou y. These two should be equal. Now we have 4 combinations. With the help of these equations, we have 4 combinations. What combinations we can have? Instead of dou u upon dou x, you can put dou v upon dou y. Instead of dou v upon dou x, you can put minus of dou u upon dou y. So you will be getting 4 combinations. And out of those 4 combinations, one of the combination was not as per the requirement in that particular question. Okay, either it was option number A or B. I don't remember the answer. I guess A was the correct answer. Okay, one of the option was not in the requirement, and hence that will become the correct solution of this. Okay, so this is a homework for you. This particular question plus e raised to the power x and plus sin x. These three are homework for you. In the next class we will be discussing this question and after that we will be proceeding further. काफी time हो गया है, ठीक है ना? So let's call it a day. Let's meet tomorrow in the class and not tomorrow but whenever the next class will be, and we will continue with this topic, that is the limit continuity and differentiability. Okay, thank you everyone. So please repeat again. Please repeat again. Dou f upon dou z. See देखो, आपका जो फंक्शन है वो एनालिटिक है, ठीक है? Your f of z is analytic in nature. What does analytic mean? Analytic means that it is a single valued function and a continuous function. Again I am repeating, it is a single valued function and a continuous function. Now, if it is a single valued function and a continuous function, now what does this continuity mean? Continuity means that your limit tending to any number should come out to be equal. Whether it is left hand limit or right hand limit, your limit should come out to be equal. Okay, so now see, ध्यान समझो इसको. आपको जो फंक्शन है, it is a function of u comma v and u comma v are further functions of x comma y. It means that whenever you are doing the differentiation of this function with respect to z, the differentiation will be done two times. First one is with respect to x and then with respect to y. First it will be done with respect to x and then it will be done with respect to y. If you do the differentiation of this function with respect to x, you will be getting dou u, which is a function of x comma y, upon dou x plus I dou v upon dou x, which is again a function of x comma y. The question is, sir, why are you not writing this? That is z is equals to x plus I into y and dz is equals to dx plus I dy. Because this was not a function, this was a number, this was not a function, it was just a number. So I was differentiating the real part with respect to x from the total differentiation concept and the imaginary part with respect to y. But if it is a function, function means that it has both the terms of x and y. So let me do with respect to x and then let me do with respect to y. And dou f upon dou z, let me do it with respect to y, that is dou u x comma y dou upon dou y and plus I dou v x comma y upon dou y. In question it is mentioned that this is analytic in nature. The function is analytic in nature, that is mentioned in the question itself. If question it is mentioned analytic, it means that it has to be continuous. It has to be continuous. Why? Because it is differentiable. It is a single valued function. If this function is continuous, it means that if you are doing the derivative with respect to x and if you are doing the derivative with respect to y, what does this derivative mean? Derivative means that the limit tending to, now df upon dx, what does it mean? It means that limit of x tending to, not x, limit of h tending to 0, f of x plus h minus f of minus f of h divided by f of h. That is what the meaning of differentiability is. That is the class 12th concept. Class 12th concept, यही तो पढ़ा हमने class 12th में कि differentiation का मतलब क्या होता है? Limit of h tending to 0, x plus h minus f of h upon f of h. This is the meaning of differentiability, right? It means that if it is continuous function, these two values should come out to be equal. Okay, these two values should come out to be equal. So whether you write it like this or whether you write it like this, both are equal. So these both are equal. That is dou u upon dou x plus I dou v upon dou x. It should come out to be equal to the differentiation with respect to y. Otherwise it will not be continuous. Otherwise it will not be continuous. Dou u upon dou y plus I dou v upon dou y. And now these have different combinations. These have different combinations. We will have 4 combinations. Out of those, one is not valid. If you put it, you will get one of the correct answers. Clear? So काफी टाइम हो गया, ठीक है ना? मुझे और भी एक और क्लास लेनी है मुझे, ठीक है? तो अभी मिलते हैं हम नेक्स्ट क्लास में. In next class we will meet and we will continue with the topic. Okay? Thank you everyone.